Hello, everybody. I put some Lone Star Drift Week 7 Naoki Nakamura merch on the LoneStarDrift.com website. If you want some, head over there. It's limited time. Thank you to all the sponsors such as Just Racing, BC Racing Custom Coilovers, WhatMonstersDo.com, who also has a new logo, and go to their website, use the discount code EBISU, Vapetasia, NK Wheels, Bolino Tires, and Heatwave Visual. Let's get started.
Hello, YouTube. We are here today at Just Racing. We're in the middle of Drift Week 7. We have one more stop. It's been going amazing. They had a big party where they rented out the top of the penthouse top floor of the Palms Casino. Everybody partied. They did rolling shots of Vegas. Maybe Sai can toss them in, where they were doing burnouts and being idiots.
That was fun.
Yeah,
gotta be an
Drift Week has
sometimes.
been craziest. Anyways, Drift Week has been so much fun and so crazy and stuff. Chris has had to work the entire thing, but we're passing through his home right now, and I wanted to make some content with Chris because I love talking with him. So today's topic is, what does it take to make like a Formula D 2JZ? We always hear about their builds or this and that. I'm not a huge mechanic, so it's fun for me to learn things because he's so passionate about engine building and engines and everything. We're gonna look specifically at Forrest Wang's 2JZ, and then also just in like the conceptual idea of building a Formula D 2JZ, because he has so much rad stuff around. So he talks so well, I'm not gonna even interrupt. Go, Chris, show us what we need to know.
Formula D 2JZ. Well, I mean, there's a lot of different ways to fuck. So obviously, like realistically, like when it comes to 2JZs, that's kind of the bulk of what we do here. It's kind of what we try to specialize in here. It's a lot more efficient for us to work on a singular platform. We could develop things for a singular platform, innovate things or whatever, right? We could put a lot more energy into it. I feel like it goes a lot further. 2JZs were something we were passionate about because I felt like they've been very problematic for people, right? So like, I feel like LSs and things like that, people have done a lot to figure that out. There's a lot of incredible machine shops in the country that specialize in the LS platform. Not to say that there are machine shops that do like JZ stuff, but I feel like there was nobody that was really putting a lot of effort into it, especially when you think about drifting as a whole, right? And I think a lot of it is I think there's a lot of misconceptions around the wear and tear and the stress of an engine that's in a drift car, right? I don't really feel like there's another parallel in any form of racing that can equate to the amount of load, stress, everything that goes into a drift car. And I feel like a lot of guys, especially that aren't around drifting, they see the tire spinning and they feel like just high RPM, low load. But that is not the case. These cars are super gripped up. So the same rules that would apply to a street car or a drag car can't necessarily apply to a drift car engine when you're talking about a 2JZ build or any build for that matter. I think I was actually having a conversation with a guy that runs Andrew's transmission, the dog boxes, right? And he was like, oh my God, you build drift stuff. He was like, I really want to point out, dude, like, this is insane. He's like, I've been rebuilding transmissions for Formula Drift drivers and helping them with their programs, and I've never seen this wear and tear. And he was like, dude, maybe offshore boat racing is the only thing that could even be comparable, right? So I think that one of the biggest things is when you look at parts, the main thing that I feel like makes us successful is there's not any one individual, including myself in here, that feels like they know everything, right? We're constantly learning and we lean on our vendors, right? There's no scenario where I've been doing this for 40 years, I could look at this and tell you it's good, right? That doesn't exist because there's a tool to measure everything, and the egos have to leave and stay at the door, right? And we don't allow that here. So when you're looking at parts, we try to lean on our vendors, our manufacturers, right? They have their own engineering teams. They engineer and design these parts, whether it's rods, pistons, you name it, right? And they supply us with horsepower ratings, right? And we try to adhere to those as much as possible. And one of the biggest misconceptions is with horsepower ratings, as I hear this a lot too, is, the standard rating when they rate something for a street car versus a drift car, right? One of them that's like, or like a race car, right? So like one of the brands would be like, let's just say like Manly, for example, right? if you look and it says like this rod's rated for 800 horsepower, 900 horsepower, you're like, okay, like I'm making 800 horsepower, this is going to work, right? But if you actually go into their catalog, there's an asterisk by that, right? And then if you go to the bottom of the page, it says 900 horsepower, but if it's going in a circle track car, it's actually only rated for 600 horsepower. So some of it is experience and some of it is leaning on our manufacturers to know and have their support, right? Because I also, if something fails or doesn't last inside of a motor, I want that support because I also want to be able to stand behind the products that I put out. So a lot of it is part selection, right? And knowing how to kind of navigate through the part selection, what things are rated for, and making sure that you're having the right part for the application and use, right? Like I said, whether it's valve train, cams, pistons, rods, starting with the right part is everything. And then from there, it's just machine work, right? Like it's measuring everything, taking the time, making sure stuff's right, having the proper tooling. It's really crazy. I'll show you guys some of the stuff that we do here and just some of the differences and the intricacies that go into what we do, right? I actually have, this is actually Forrest's block right here. It's just, so this year, this thing we're just getting ready to paint, we like cut out these like templates out of like a magnet material so that we could just like slap them on and then spray paint them just to make life a little bit easier. But we had already machined this block. It was just getting ready to paint. We did billet main caps, ARP main studs, bore and honed it. We actually already had built the block for Forrest last year. We had built it 2 motors. We weren't sure if FD was going to be an option or not for us. And it wound up not being an option last year. This year, he decided he wanted to do nitrous as well. So we wanted to do gas-ported pistons. And then when we did the gas-ported pistons, we were running a total seal top ring set on his piston. And we decided to move the gapless ring that was total seal to the second ring, and then the top ring is now going to be conventional. So we've altered his ring pack to make it a little bit more reliable with nitrous, since he's going to be changing that up. So some of these things, like I said, we could talk all day about. And
do you
like
have any of those pistons we can see in your hands?
Yeah, I'll have the guys grab them. Maybe we'll have to chop this up and then and do that. But yeah, I'll actually show you some of the pistons that we make and then why we make them.
Wait, you make the pistons?
Well, I don't technically make the pistons. I have them custom made for me.
Okay.
So they're not like a shelf part. So they are unique to us. So just depending on what it is, right? So, but yeah, so this is his block, but like I said, it's just unpainted. There's nothing really too special about it. And this one is just another core. Obviously if you walk through my shop, there's cores everywhere, man. Like we're constantly buying cores and we just build 2J after 2J after 2J. It's probably 50 to 60% of what gets done in here. The rest is LS. And then we have this problem where by myself and Justin, my partner, like we have a hard time saying no to things. We love race car shit, and like if you're passionate about it, so like there's a small percentage of weird stuff in here that's like odd motors. It's a nightmare because you just get so used to like running the same thing over and over again that like fixturing and things like that, like it becomes very easy to like pull one block off and replace it with the same exact one. But then when we switch from like inline 6 to V8 platform like LS, then a lot of things have to get reconfigured. But I'm not sure if you guys want to do like a rundown of like a lot of the machinery, so I could kind of explain how they correlate with a JZ maybe.
Explain to us exactly what you do to the block. Let's just start there. It's like, what do you do to the block? Show us on the machines. Like, you're not obviously doing billet blocks. You're not doing anything crazy. It's just an iron 2JZ, GTE, or GE block, right?
Okay,
Nothing
yeah, so I'll show you what basically, I'll explain to you what some of the stuff we did on this block was in particular, and then I could show you some of the processes in front of the machines as well.
Okay.
So this block here, could probably tilt it up.
You need smell?
If I drop it, don't air it. Oh shit, there's no main caps in it. Okay, so this block, we've deburred the inside of it. So basically we go around, we deburr everything, all the loose metal bits and things like that that could potentially come off when it was running and cause any kind of failure. This one's had ARP mains in it and billet main caps. Other than that, we surface the block. We use a CBN cutter to surface it. And then we bore this block to 86.5 millimeters. So depending on the application and what we're doing with the block can dictate what it is, right? So like his previous motors, the ones for last year were 86.25. So a little bit smaller, so 10 thousandths oversize from 10 thou oversized from factory, because we wanted to use the smallest piston option available, and he was making about 950 to the wheels. So we want to use the smallest piston option available and leave as much meat in the cylinder as possible. Since we're switching to nitrous, we've opted to go to 86.5 millimeters. And the reason for that is the rings are typically like, nobody makes a ring that's actually 86.25. They're cut down from a larger diameter. So 86.5 millimeters is actually a standard ring, right? So when we take the ring and we have Total Seal cut it down, even though it's only 10 thousandths, we lose a very faint amount of the radius. So running an 86.5 millimeter piston, that ring is actually technically stronger. And while we didn't need that before without nitrous, the addition of nitrous is the reason why we stepped back up to 86.5 millimeter. Not because the block was already machined or whatever, right? Like I said, it's just kind of application specific, depending on the needs of the motor at that time. Nitrous is a big variable for us, and we want to make sure that this is reliable under those circumstances. But other than that, I mean, realistically, it's just machining it, torque plating it, machining it with, the head studs that we're going to be using, bore and honing it, things like that. So like, and the nice thing about going to 86.5 millimeters too, on some of the more high-end stuff, is we could actually blueprint the blocks as well. So we could send a boring bar down through it, and we could use our CNC machine to locate that based off of the blueprint. Otherwise, if we're doing less, like 10 thou oversized, 5 thou oversized, I even make custom pistons to just go 5 thou oversized to leave more service life in the block. When we do that, we have to center everything off of where the actual cylinder is currently. I can't alter that. But if I have a little bit of meat and room to cut off, I could actually send a boring bar through it and blueprint it based off of the factory blueprint that Toyota provides. Like the blocks are just cast, so over time they settle. And then when they settle, over time, things shift a little bit. So they're never perfect. They're small, minor differences, but it's too risky when we don't have a lot of material to cut to go back and try to realign things back to the blueprint. And oftentimes it's really unnecessary. There's not a super need for it unless we're doing something really crazy. Other things that we did to this block would be they're drilled. So this block here, basically all the blocks, this is actually a GE block. So this is a non-turbo VVTi block. So this one, all we did was we drilled the oil passage through. So there's actually an oil passage that runs along the front of this block. I don't know if you can see it probably in this block. But if you look down here, there's a small bulge right here. And so that is an oil passage. That oil passage does not go all the way through on a GE block, but it's actually the same as a GTE block. So what we do is we take a drill bit, we go down the side, we drill through the side of the block, and then it's hollow, and we pass through, and then basically we punch through, and it puts oiling on this side of the block, your exhaust side. So like this one's already has it done. The oil's pushed through to the exhaust side of the block, and then down here, these pads are just blank, and we drill and we tap those, so that way you could actually feed oil out this side of the block instead of having to run an oil line around, right? So the block is actually technically the same, right? From GTE to GE, it's just the finished machine work that's not done.
So for stupid people like me, that means all GTE blocks are actually original GE blocks, and then they drill that, and that makes it a GTE block.
I can't say in 100% confidence that they don't have a different mold, but I've gone through and I've measured everything, and they're structurally identical, right? Okay. And so the only difference is finished machine work. And I've even taken for customers, it's rare, but there's been events where like there's been shortages on GTE blocks, right? And they want a GTE block. And I've actually taken GE blocks and machined the pads back down for the oil squirters, and actually added oil squirters back into these GE blocks. As long as we allow oil to pass through this side of the block, and then we have access to our turbo oil lines originally, and then we can bring back the oil squirters. Like I said, very odd request and very rare, but something we can do as well.
So this was a GE block?
This is a GE block.
And are you going to put oil squirters in it?
No, we're not. For drifting, especially your shorter run times, and you know, we're running Q16, I believe. A lot of guys are running either Q16, E85. We just don't see the need for it, right? I know a lot of people believe in like even deleting them. It was a common thing that was like happening, like let's say drag racing and things like that. They feel like the oil would be better used somewhere else. They're running a shorter distance. It's not something I would ever remove from a motor, right? But it's not something I would add in, right? And like usually the customer that wants the oil squirters and demands them is willing to spend a little bit more money and start with a GTE product, right? There has been a couple cases where that isn't true, and there's people that have added oil squirters. We also have the ability to add the oil squirters back into these. Very simple job. Just doesn't make a lot of sense, right?
Okay.
It just makes more sense to start with a GTE block at that point. And also, like, availability is a big deciding factor, right? Because since COVID, right? Like, availability of parts, they come, they go. And like I said, that's another reason why we specialize in specific platforms, is because of we're able to house inventory for that platform. So for the 2JZ platform, I probably have at least 200, 250 sets of rods in stock.
Oh, wow.
Like every manufacturer you could think of, whether it's overseas, here, even like niche stuff. No, like the real like drag racing stuff or like aluminum stuff, but like pistons, I've got a whole wall of pistons from every manufacturer down to our own custom spec pistons, but like bearings, gaskets, like anything you could think of for a JZ, we stock all of it. And it's how we've navigated through COVID, right? If I was doing a variety of engines, I wouldn't be able to have that, and I would have to struggle with every single build, right? And that's another thing that makes 2JZs more viable for us. And you know, eventually, what we plan to do is like if we could ever get caught up. Funny enough, you know, just like word of mouth is crazy, right? With just word of mouth alone, we are slammed all the time, right? So we're constantly trying to bring on new people, expand, but it's tough, right? So, but eventually I'd like to have pre-built stuff on the shelf, and we could do work based off exchange. I'm constantly buying stacks of cores. I've got cores stacked up there, here. These are new cores coming in. Some of these are cores that are passing through. There's another core that's passing through. That's not a customer's motor. Some of the stuff over there's customers' motors waiting for teardown. There's always a mixture, right? But I just can't ever seem to get caught up. I buy 10 cores, and we're like, okay, we're gonna get all these cleaned up, get them ready to machine. We're going to build all these motors and put them on the shelf. And the next time a customer comes in the door, we're gonna, instead of selling them a build, we're just gonna take their motor in as a core and sell them something on the shelf, get them in and out the door instantly, right? They just keep coming.
Yeah.
The motors keep coming. So
Machine shop stuff has been so rough for me the last few years.
It's tough for everybody. Like I said, we're definitely a little bit behind on this. We had to make some adjustments. So we had to do some things in the cylinder head, things like that.
Yeah.
So we had to do some adjustments to his motor to kind of fine tune it a little bit, dial it in a little bit better. But we should be delivering this. We actually have everything done on this. We just got to do the assembly portion of this. So we should be delivering this by this weekend to Forrest.
Before we move on and keep showing us more stuff, why isn't it a 3.4 liter?
I think that Forrest wanted to go back to the 3 liter, and he made that decision before we even started building the motors. I know he was having a lot of problems before. A lot of them were machine shop related, right? Not all machine shops are created equal. But I think that he's happy with the performance with his turbo setup and things like that, right? So I think before, when he was on Garrett and before like the G series stuff came out, he was on some like a 4076 or something like that, and like he was on some of there just wasn't a turbo that really fit,
They have
right?
a 4076?
Or
I thought it was like 4088.
Or 40, whatever, I don't remember what it is,
Yeah.
right? And then there was like another series that they had that was like a weird.
I think he ran a 42R for a while as
Yeah,
well.
42, but that's what it was, a 42R. But he's had like all different kinds, right, of turbos, and they just didn't offer the response, right? So in order to hit the power levels he wanted to hit, you know, they were hitting full boost 5,500 RPM and higher oftentimes, right? It just didn't make any sense. So he had gone the stroker route, and they had ran into some issues with that motor. With the machine shops and stuff and getting them built and making them reliable, they were just failing. He was having a lot of failures. It wasn't a part issue. It was a machine shop issue. So at that time, so he decided to go back to 3-liter, and he had some success with it. But playing with turbo setups, we were able to get something that was much more responsive. It couldn't make the 1,200 horsepower or 1,300 horsepower some of his previous setups had made, but he didn't really need it in a lot of applications, right? So I think this is kind of another variable where he has, you know, with a 3-liter, he has the power he needs, he has great response, and if you add nitrous to the mix, I think it works very well for him. It gives him a little bit more tunability, flexibility, adjustability. I do think at some point I would like to get Forrest onto a stroker motor, but right now, today, it's kind of his comfort zone, and he hasn't had nitrous really in his program consistently throughout a season, right? So I think that it makes more sense for him coming back into Formula Drift to come back as a 3-liter, and we know that's working. We know the recipe. We know these motors are working. We know they're reliable. We know that he's going to be able to do a season of drifting on these motors, and then we're going to toss in the variable of nitrous, right? And we're going to develop that throughout the season, right? Him and his team is going to develop that throughout the season. And I think that's going to be the focal point, right? I think when you're there at Formula Drift, especially coming back after taking a little bit of time off, the less variables, the better, right? The less things you're trying to figure out throughout the season, the better, right? And dial in, right? So I think it makes more sense, rather than trying to figure out a lot of different things and making a lot of changes, to just give him what he already knows and then play with the nitrous and get comfortable with the nitrous. And then next season, if he feels like he's coming up short and he wants to step up a little bit in turbo, we can have a discussion of doing a stroker motor at that time and just catering it to his needs, right?
What specifically kills the stroker motors? You said it was machine work.
I don't want to throw anybody under the bus, but you know.
What theoretically, because I remember Greddy with Ken Gushi, I think they killed like 5 motors in like 2 events or something. I don't remember this was years ago, but you remember the rapid fall of like stroker motors in FD for a little while? What was causing that?
Stroker motor specifically, I don't know. I can't comment too much on other people's programs because I didn't see the aftermath of it or know the actual cause of the problem. There are people in FD that I've talked to about these problems and was helping them resolve these problems. But I've seen a lot of failures due to oiling, right? Number one failure, right? And that's not a stroker issue, that's across the board, right? I've heard this done many ways, but it has to do with billet mains. And I've seen this time and time again with people. You know, like I told you, like Fruit, we were at lunch and Fruit called me, right? So I had talked to him about it briefly. His program was going fine, right? And he has a good machine shop that he trusts. And we've spoken about this issue, and they were very honest about it and upfront, and I have a lot of respect for whoever is helping him with his program. But he wasn't having reliability issues till billet main caps went into the motor. And what happens is on a 2JZ, or most import motors just in general, you have an oil pump that locates on dowels. So that oil pump is fixed in position and is machined. The engine is machined. The mains are machined in line with your oil pump, right? Now, if you go back and you put a different main cap on there, what you do is you cut the cap down and you shrink the circle down, right? And you make the circle smaller, right? And then you go back through with a mandrel and you open the circle back up and you make it perfectly round again. The problem with that, the process of a line honing, right, is, and I've seen this done a couple different, there's a couple different ways to do this with this machine, but you have a mandrel that passes through all of your main journals, and that mandrel has no memory, right? So that mandrel can flex upwards, downwards, whichever way it wants to go, right? All it has a shoe on one side and a stone on the other, right? And the shoe pushes the stone and keeps things centered as it rotates, and you use a drill. It's a very basic machine to spin this mandrel in there.
It just looks like a rod that's reaming the entire thing, right?
Yeah, and I can
just a big long rod.
Obviously I have one I can show you as well.
Okay.
So with that mandrel, it has no memory, right? So now you're taking a block, right, that has it's cast iron, and then you have a main cap that's cast iron, right? So you have very comparable materials that you're turning this mandrel through. Well, now we're taking the block that's cast iron and we're adding billet steel on top of it, right? So now one side of this hole is billet steel and the other side is cast iron. Well, billet steel is considerably harder and more dense than cast iron. So the cast iron becomes much softer. So what happens is as you're taking that hole and you shrink it and you go to enlarge it, you're only able to shrink half the hole. You're only able to shrink the cap side. You can't shrink the block side and cut it down, right? So now you take that mandrel and you expand it back out. What happens is it starts to walk deeper into the block than it does the cap. So now your crank starts to sink into the block, closer to the deck surface. Some are able to do it with less, some a little bit worse, right? So what happens is you have a big misalignment issue with your oil pump. So that was the number one thing that I see failure-wise in drifting is if you sink your crankshaft into your block 3, 4, 5, I've seen worse, right? Then you have a misalignment issue with your oil pump. That creates excess heat, you're on the track, you're drifting, you start locking up oil pumps, you start having oiling issues, and then a guy like that goes from, one engine for a whole season, even built motors, to one engine around. And it becomes a nightmare, and you're living your worst nightmare. Same thing with Forrest, right? Like we went, there was one year, Seattle, oil pump locked up, misalignment issue. Next, but he was having some problems with just in general, right? We had the backup motor. We had 45 minutes to swap it in. We pulled it off, went to crank it, stuck. The engine builder, I'm not saying that he didn't use some sort of lubricant when he put the pistons in, but you have to talk to your clientele and you have to know what they're gonna do with it, right? If this is a spare motor and it's going to sit in your trailer, and we know that's not going directly in your car, we use things like assembly grease. When we put pistons and things like that, we coat the cylinder walls and stuff like that, so that way they don't rust. So the spare motor that we have, the piston rings and stuff were actually rusted to the cylinder walls, and it was completely locked up because the person that assembled it didn't grease everything down, but when they assembled it, they weren't accounting for the fact that this motor wasn't gonna get fired up right away, that it was gonna sit, right? So you have to have conversations and communicate and talk to your customers and know what they're going to do with that, right? And that was a very troublesome, year for Forrest with engine problems. And it all went back to the machine work, and the assembly work that was done to it. So some of these other motors, I don't see any reason to, like a stroker motor, why stroker motor in particular would fail. If outside of oiling issues, I would venture to say the next number one problem that I would see, so I guess the number 2 issue would be balancing. The importance of balancing. Balancing is so critical. It is the most critical thing in an engine. I don't think people understand how critical it is and how specific the specs need to be, right? And this just goes right back to a JZ just in general, right? And why this motor is so great, and especially for its time, right?
You want to walk in there and keep going?
Yeah.
That's loud. The machine shop room is quieter.
Yeah.
Ooh, this is nice.
So we could actually talk about some of the stuff that I was mentioning. So basically, we were touching base on main caps, right? So here we have a mandrel, right? So you have cutting stones on one side. Opposing, you have shoes. and this is what keeps it centered, right? This mandrel, we have bracing to hold the mandrel rigid, and then you have a drill that attaches on this end, right? And basically we spin this, and then we have a knob. We're able to expand it till we hit the size that we need on this mandrel. If you use something like this on billet main caps, it's gonna fail, right? And we see a lot of people get comfortable, right? And this is another thing, like there's enough, it's 2023, right? And this is the same shit I tell everybody, right? All my customers, right? It's 2023. You can have anybody, anywhere, build you a motor. You can have anyone in the world tune your motor, right? So why wouldn't you go to someone that specializes in this stuff? I'm not the only one that specializes in 2JZs, right? Why go to your local machine shop, right? If it's sensitive, if you're competing at that level, right? And it's that sensitive, go to someone that's an expert in your platform. You know what I'm saying? If you have a Ford motor or something, don't come to me. I do build a lot of Ford stuff, but whatever, you know what I'm saying? Like there's someone for that, right? That specializes in that. And so this is the #1 killer of JZs right here. There also is another mandrel that uses a single bit cutter that is more precise. But it's so unstable, you can only cut about 5/1000ths from size, and then you have to finish it with stones because of how unstable this fixture is, right? And so that's better because you're only shifting the crankshaft a small amount, but it's not ideal. And the real solution in FD, right? And this was where things changed in FD very fast, was the inherent need for dry sump, right? And I really feel like dry sump changed everything, right? Because you no longer have to worry about misalignment issues with your oil pump. And that's why it changed everything. And there's a lot of other advantages to dry sump.
So if you run a dry sump, you can make it all survive with the line hose.
Exactly. You could fuck this up, but you're no longer driving the oil pump off the crankshaft. And so then you don't have those issues anymore. So dry sump was the biggest turning point, right? And then if you look around at like who's really having problems in FD, right? Still with JZs, typically they're wet sump, you know? And then some guys just have good machine shops, right? Like you see like Rad Dan, I'm pretty sure he's still wet sump, right? Rear sump though, right? Which is it's much better than a front sump, right? He's rear sump, right? So in that regard, right? Like he's got good machinists behind him and they're doing good work. I know the shop that used to do the machine work, I don't know who's doing it now, but they did use a mandrel, but they used it with a single bit cutter, right? So it's much more precise. But I've seen people actually try to take stones and do billet mains, and it's the kiss of death, right? You'll never make it, you'll never survive. But that was actually one of the first things we aimed to resolve right here.
This looks like a very expensive machine, good God. Instead of, look at this, Si. This machine is literally a giant drill, like mounted on a fancy arm. You just attach it and you just like ream this thing back and forth by sliding it on a rod, I assume. I don't want to touch anything and mess it up because things are calibrated probably, but like that's what you do. And then like this is a gigantic, fancy, look at how much that thing must weigh.
This is pretty simple, the software on this. So this was actually a tool that we had worked with Rottler to develop, right? So this tool has existed for quite some time. And basically what this is for cutting mains, right? One at a time. So we go in one hole, second hole, and we just literally one at a time go right down the line and cut each one individually with a single bit cutter. This has never existed in a format that would fit in an inline block, right? So this has existed previously, but it was a much bulkier unit. It was gear driven. We actually scaled this thing down and it's driven by a timing belt now. So it doesn't have the torque that, and certain jobs can't be done with this, but for cutting mains, it's perfect, right? And so we worked with Rottler to design this tool, and it's the first of its kind. So we could actually go in and we can cut accurate to a 1/10 of a thou. Cut exactly what we need, right? If we see that there's distortion in the block or something that we need to clean up, we can cut a thousandths oversized, right? And run a bigger shell top and bottom, right? I could drop the head a half a thousandths from center. And I could run a half thou, or oversized bearing bottom, standard top, right? I know exactly where the crank is in relation to where it started, right? Obviously with these blocks, things shift around over time. It's impossible for me to get an exact measurement of where something is because there's not a good reference point. But on something like this, like I said, we can go right down the path, straighten this thing out, get everything exactly where we want it to be on something like this, and cut these caps, and just cut the cap, right? Whereas this, like, I don't have a choice but to cut the block with a mandrel, right? With this, I can just cut the cap if I want to, right? So I have zero chance. I'm not gonna shift your crankshaft more than 1/10 of a thousandth, right? Versus anybody with a mandrel can only guarantee that they're gonna shift your crank 2 thousandths or 3 thousandths, right? There's a window, but they have to shift your crankshaft around. So you can feel the lip, right?
Yeah.
The actual cap is much smaller than the block. So basically,
and it's obviously so easy to see the dissimilar materials.
well, every block is different, but what the object is to take the cap and marry it to the block, right? Every cap is married in the position that it's in. So it has to be, the hole has to be considerably smaller and get opened up to match. So that way it's a perfect match, because every single one is gonna have slight variances in it, right? So with this tool, and this tool is, like I said, we developed this tool, but we didn't like go somewhere and have a tool proprietary to us that we controlled, right, made, right? I could have done that. I went to Rottler and had this tool made, and then I had to put it in the catalog, and anybody can buy this tool. I think I've seen Branger's Racing with this tool, Advanced Cylinder Heads with this tool. I believe they're in Florida. So there are places with this tool. You don't have to come all the way to Las Vegas to use this tool, right? I wanted to make sure that, like, you know, solutions that get developed for these platforms are accessible by everybody, right? But also, like, it's a $30,000 chunk of metal. You know what I'm saying? It's like ridiculous, right? So you're also not gonna find this at your local machine shop, right? But people that do specialize, do a lot of inline stuff. I'm seeing more and more adoption of this tool, which is awesome, right? The goal here is to advance the industry in any way, right? And just be a part of it, right?
So is that all this thing does?
Yeah, I cut mains with it. So there's other things.
This whole thing is just to cut mains.
Not the whole machine, right? This table is right here. And this tool right here. There's other jobs you could do with a right angle tool. Typically we use a gear driven one for other jobs. So I could do like cam bores, things of that nature with this tool. And I drive a mandrel with this tool. So I could use it to drive mandrels and other things. But for the most part, this tool, we only use this tool for mains and inline blocks, and that's it. That's its only function. This is a Rottler block machining center, so we use this for any function pretty much that you could do on a block, as long as we don't need to roll the block over, right? So there's certain jobs where we could be more precise if we have the ability to roll the block over with a 4th axis. So we have one that has a 4th axis. But some jobs, right, like it's not a huge difference, but the 4th axis is a lot of weight, right? So we can move the 4th axis around and we can move it off the table. But every single time I do that, I have to recalibrate everything, right? Because it's not a huge figure, but 1/10, 2/10, things will shift by removal of the 4th axis, right? So that's why we have one that's 3 axis, so we never have to remove anything from it. And jobs that just require 3 axis, so like like we could surface on this, we could do mains on this block, on blocks, we could bore on this machine, everything like inline block related. Most functions happen here. It just depends on what it is, but. Yeah, for the most part, it's a big machine that we just line bore on, right? It's a lot of fucking money to just cut main caps. But on 2Js, we cut a lot of them, right? So it just depends on what exactly it is.
How many of these things do you have to cut before this machine pays for itself?
I don't even want to know, right? Because I don't even know if I'll ever get there, right? Like, I don't really have any aspirations to be a big machine shop.
You're
right?
just passionate about this.
I just love.
Like
I just enjoy this. I don't really have any desire for this to be a huge operation. I can tell you that this machine is pretty expensive. It's not too bad until you start factoring in tooling, right? So like the first machine was probably 200 and something thousand, 250,000, but it was a lot of tooling, right? Where this one wasn't as much tooling, so it might have been 150 for the second machine, right? So because we forego a lot of tooling because we already had it for the first machine, right?
So you have like $1 million of machines in this room to build 2 JZs for people to do burnouts.
Yeah, that's about what it is, right? I think there's some important features about some of this. I think the most important thing about this machine is that, and the reason why we did some of this stuff, right? So like, is the spindle RPM, right? So we actually have like dedicated block machining, like engine machining mills, right? Where like I even see some machine shops where they try to convert other types of mills to work and fixtures for other types of mills, your standard Haas mills and things like that. And those work, in some cases they're only as good as the operator, right? But when you deal with some of those Haas mills and things like that, they have very high RPM spindles. They can have 25, 30,000 RPM spindles. But when you have spindles that operate that fast, they're not as precise. So then you're accurate to 1,000, things like that. But when we're talking about making a hole perfect, you need to be accurate to 1/10. So these are special low RPM mills. So that way, like, I can't cut parts. I'm very limited to what I could do. I can only do machine work. I have a full CNC mill that I can only do machine work on. But that's also why you don't see like the big enclosure, coolant, all those things, because we just can't cut fast enough to justify the need for all that. Because everything gets cut super slow here. But it's how, like I said, things get cut accurate to 1/10 of a thou. Like most machine shops, when you're running on manual equipment, all your gauges are in 0.5 thousandth increments, because that's as accurate as you're ever gonna get. And here, everything reads tenths. Everything is as good as it came from the factory, if not better. And we try to perfect on every little thing that we can do here. I'll show you guys some of the other machinery that we have. Real quick, I'll give you kind of the quick tour, since we kind of have the rundown on some of that stuff. So this is our CNC cylinder hone. So this one automatically goes from hole to hole, which is more of an efficiency thing than like a functional thing. But this machine will actually sense highs and low spots. It will straighten as it cuts material. So it's considerably more efficient. Again, this one is accurate to 1/10 of a thou. If you have your settings correctly, it goes from hole to hole, up, down, every direction, from cylinder to cylinder, within 1/10 of a thousandth. And this machine is amazing. The learning curve, get these dialed in, is very difficult. I've talked to a lot of people that are very against these machines, but if you take the time and you figure it all out, there is just nothing else like it. I had cut with everything from, so these are the heads that go in. These are 4-stone heads. I have everything from 4-stone to 6-stone in every size you can think of. Typically 4-stone heads we use for finish work, right? So almost every block that goes through these machines is a 3-step process. So we use roughing stones to size. And those are done with a 6-stone head for concentricity, right? And then from there, we step up. So like a roughing stone might be 80 to 120 grit or something, let's just say. And basically, we're putting a crosshatch in the background. So this will CNC cut crosshatch angles perfectly, top to bottom, like you name it, right? And so we get our crosshatch, we get our depth of our cut, right? And then we come back with like 200, 220 grit, and we plateau hone. Which is different than your standard honing, right? Is where we set the amount of strokes that it takes, and we brush up and down, and we knock down the coarseness that the roughing stone's left. And then from there, we come back with a finish stone, which is probably around 600 grit. And that's what gives us like a mirror-like finish inside, right? And that's what you see a lot of people like manual machining. You'll see like a very dull, coarse, rough-looking finish, right? But then when you start your car up and you run it, you do your brake in. If you ever go back to that motor, it's like a mirror. right? Because you're relying on the piston ring to break in the motor. With this, we use stones and we break in the motor, right? Because if I'm gonna machine something accurate to 1/10 of a thousandth, I wanna know where the final size is, right? If I finish a bore and I'm allowing the piston rings on break-in to finish knocking everything down, right? And settling in, I don't know where things are. I don't know if I'm still accurate to 1/10 anymore, right? And that's where it's important for us to do the finish work in the machine. So every block we do all the finish machining here, the cylinders, and another thing too is what's becoming more and more popular. We try to use total seal rings as much as possible, but it's created a lot of pressure on the industry for piston manufacturers to start releasing things like specs for cylinder walls, crosshatch angles, whether it's RPK, RVK, different ways of measuring surface finishes. When I finish a bore, right, and it's completely 100% done in this machine, I know what it's gonna look like even after it runs, which gives me the ability to use what's called a profilometer. So it's a gauge that we run inside the bore, and it tells me all the specs, right? The depth of the cross-hatching in the background, it tells me everything, right? And someone like Total Seal will give me all their required specs that they want to see. And if I put out a motor and it has any bit of blow-by in it, right? And it comes back to me for that. And I can go and I can measure with a profilometer that we met those specs that Total Seal requires for us. Total Seal won't just refund us, they'll pay for everything. They'll pay for our labor to replace it because they know that if we operate within this window that's measurable and definable, that it's going to work. That there's no doubt in their mind, right? That it's not like other warranties, right? And so you're seeing a lot more pressure. You're seeing pistons out of the box starting to be included with these things and this data, right? That needs to be measured with a profilometer. But if I don't finish that cylinder 100% the way it's gonna run, I don't have a way to measure and take all of that data back in, right? And make sure that it's perfect, right? And that's how we know whether things are going to seal before they leave, right? And that's why, like, even when we talked to you guys or Mark, I said, break-in's easy. Throw it on the dyno and just heat cycle it, right? And it was like, you're gonna see maybe a little bit of puff, of smoke coming out the breather, and then it's gonna seal right up, like that. Like, you're not gonna have to go put miles on this, do a bunch of pulls. It's literally gonna, you're only heat cycling the motor to get grease out of it, right? It's going to break in instantly, right? Because all that work is already done for you before you get to it, right? So,
1 second. Did you do a new clip? Look at him, not me. He's the talker.
We could go through some of this other stuff a little bit faster. So this is basically the same as the first machine. It's just got a 4th axis on it. So we can roll over. You need this for V8 stuff. You need to be able to rotate the motor back and forth, make sure everything's square, aligned. Sometimes we do see, on this, we'll see a inline block. Usually if it's boring, sleeving, this is actually a BMW block. This one's going to... I was just
going to say, that looks completely different than a JZ.
This is not a JZ. So this one is actually going over, I think, to 90 millimeters, 89 millimeters. I don't remember what this job was off the top of my head right now. Sometimes we'll use like rollover fixtures, like for like the JZs, where we'll do like threaded freeze plugs. Sometimes people want like unique stuff like that, right? So we have the ability to do that with a rollover fixture. We can flip the block upside down. We'll use this machine when we do like oil squirters and stuff like that. And because that on that machine without the 4th axis, if I'm doing the underside of the block and then I'm doing this, and then I'm gonna service it, we just gotta keep flipping the block, right? Where if I know I'm doing multiple jobs, then I'll use this machine, right? Because then I can flip the block over. I could do oil squirters, I could flip it on its side, I could do threaded freeze plugs, I could do your oil ports, I could do a lot of different things, and I could flip it right side up, bore the block, surface the block, whatever it may be. So I think this block is the first one we've done like this, where we've gone so much larger on the bore diameter. So I believe that Justin's just in here writing programs for this right now, because we have no program set for this block in particular on this machine, because we haven't done this bore diameter yet. Most of the blocks that we've done BMW-wise have been for boost, where we've left the blocks the bore diameters alone, right? And we left as much meat in there as we could because they were running turbos. This was going to be an NA motor, so we're going a little bit bigger on the bore. So we're just going to write a program for this. We use Ryan Shaw probes on all of our machines. We'll probe the whole block, write a program, find a factory blueprint, and then we'll relocate everything and straighten everything out back to where the blueprint was, since we have meat to take a cut. So this one will get blueprinted. The rest of the machines are just valve facing. This is just a seat and guide station. So we'll do everything from, like I said, just basically that's it, seats, guides. We can do a lot of other little tricks with it. We clearance JZ heads in here for cams, like larger lift cams, things of that nature. I do have a Newen 2-axis CNC valve seat cutting machine. It's not set up currently. We are getting ready to kind of shuffle the machines down and put that into production here next. That's a really nice machine. We're not using it currently. This one does a very good job. We plunge cut with this type of machine, and it's the way it's been done for ages. The 2-axis machine, we get slightly better surface finishes on it. So the integrity of a surface finish, when I say like I want things like mirror-like surface finishes, it would be like sub 50 RA surface finishes. I know that like a Newen 2-axis CNC valve seat cutting machine, we could see even sub 20 RA surface finishes, which far exceed the need for even like a head gasket to seal. And with less imperfection, you have less wear. The impact of those things when you have coarse finishes on them is imperfections in the surface. And when those imperfections get knocked down, the actual values of where things sit start to change and things start to shift and they settle in, right? So that's where, like, when I talk about the way certain things are cut, right? It's better to cut things with like a single bit cutter. Sleeving is another one that gets like really screwed up all the time. It's insane. People dropping sleeves, I deal with it all the time. And like I said, probably 50% of what we do, probably not 50%, but probably 30, 40% of what we do is other machine shops, you know, like whether they dropped a sleeve or something, I don't have to redo everything, right? So very common, but surface finishes are everything, and there's a way to measure all of that. So that's the stuff we're not really, I think the guys are kind of staying out of here right now because we're back here, but that's kind of stuff you don't really get to see as much of. But when we're done with things, some of the important details that are measurable. This machine here is just a surfacer. That's all it is. Nothing fancy. It's just more efficient sometimes. Like if the big machines are tied up, like we got a block on that one, we got a block on that one. This guy's doing a cylinder head, he pops a cylinder head in here, so that way we could leave these freed up for the blocks. So sometimes we do blocks in this machine if those are tied up. It just depends on where we're at in the machining process with everything.
This is the only dirty machine.
They might have just surfaced something. Balancing, not a ton of technological advances in balancing. And this is kind of to touch back on the 3.4 thing, right? And a lot the same with a lot of other things, balancing, right? The standards for balancing, right? So realistically, the train of thought is like GM, right? An LS. And this is most V8 platform engines, V platform engines, right? They're balanced to about 0.5 gram, 500 ounce inches, right? That's where they're balanced to. That's the tolerance from the factory, right? From GM. Typically, NASCAR is kind of like the standard for balancing for like race engines, and they're at about 0.2 grams or 200 ounce inches for balancing for, like, let's just say NASCAR for racing series. So considerably tighter tolerances than like your factory GM LS, right? One of the things that made the 2JZ so great for its time, even the 1UZ, is when they partnered with Yamaha, and it was for sound, right?
Well, I want to do a whole episode on this.
Yeah.
Don't waste all that.
Okay.
We'll do that in an episode real quick. It'll be short. Yeah, I love that.
But like that's part of like the balancing thing is like what gets promoted in this industry is laughable to me, right? Mm-hmm. And this goes to all of our aftermarket suppliers for rods, for pistons, and things like that, right? Like rod manufacturers, they tell you that you can't modify these rods or there's no warranty, right? Mm-hmm. So you can't touch the rods, right? And what they expect you to do, right, is and usually rods ship like with a maximum of like 5 gram variance, right? That's absurd, right? 5 gram variance, right? And then what they expect you to have is a set of pistons that have a big variance, and then you to mix and match those together and make combinations that are 2 to 3 gram variances, right? Because they don't, for them, it's an efficiency thing as well, right? They don't want to modify these rods. They don't want to sell you a brand new rod with grind marks on it, right? So it's kind of become fairly standard in the industry that you have that 2-3 gram variances are acceptable, right? For balancing a rotating assembly, right? So like you balance your crank and then you balance your rod and piston, right? And that's kind of become the standard, right? Or I see a lot of people just pulling things out of the box and putting them together, right? So when we talk about things like balancing, it's the most important thing in the engine, right? And if I balance a crankshaft to 0.2 grams, that is a factory 2JZ crankshaft. If a 2JZ crankshaft is good, it balances out to 0.2 grams of this machine, right? And that's what it was balanced to from the factory, 0.2 or better, right? And if I take your rotating assembly and there's a 2 to 3 gram variance between your rods and pistons in each journal, is that crankshaft still balanced to 0.2 grams? Or is it not, right? Because the things that you're attaching to that crankshaft are not balanced within those same tolerances. So everything in here, we match weight to 0.1 grams, right? Because we don't want anything that we put inside the motor to alter the balancing that is in the crankshaft or change that, right? Because of how critical the balancing is, right? Same thing with like wrist pins, another common issue. Wrist pins, people feel like you just put them in and go, right? Piston manufacturer is not the rod manufacturer, right? So the piston manufacturer may size the piston to the wrist pin and make that match, but the rod manufacturer doesn't, right? So we go in and we measure every single rod and piston and wrist pin, and we verify the clearances, and we have to open them up, right? So we'll take our biggest one, like, so for, we try to keep a window of like 8/10 to 1,000th. If we, on the rare situation where we have one of the pistons is at 1,000th clearance, we'll match all of them, and that's where we don't mess around, right? 1,000th, like if it's 1,000 or 9/10 clearance from on the piston to wrist pin, then every piston needs to go to 9/10. Every rod goes to 9/10, right? And they're accurate right on the money to each other, period, right? Because that's also load, right? The amount of oil that's allowed to get in between any orifice, right? Whether it's a bearing, whether it's a wrist pin or whatever, right? Is resistance, right? And that affects the load that it applies on things. But it also directly relates to the balancing, right? If one piston has more resistance going up and down versus the next, right? Like how well balanced is that firing sequence, right? So we match them all identically on every build that we do. And that's very, like all these little things are keys to creating reliable engines, right? And it's not to say that like, look, you know, like some guy on the forum put this motor together, right? And he made a ton of horsepower and it's worked out great for him for years, right? But when you're competing, you can't take those risks, right? Because every success story on something that's kind of just tossed together, there's just as many failure stories, right? There's things that just won't work at all, but oftentimes there's things that people just get away with, right? But when you put this much effort into something, just getting away with something doesn't work for everybody's program, and for some people it does, right? And that's good for them, but right, we're here trying to support those people that they need results, and they demand results, right? And they want, like, and this is the way I've explained it to a lot of even our customers. So I've had some customers come in and they're just like, you know, and I'm like, okay, look, let's think about this for a second. You drove all the way to the East Coast to, let's say, compete in Pro-Am, right? How much did that cost you? And then you got there and you couldn't compete because you had an engine failure, because you wanted to save a few $1,000s on some parts or whatever, right? And you found someone on the internet and you're like, I could do it. This guy got away with it, I'm gonna get away with it too. Maybe this time you weren't the one that got away with it, right? You were the guy you were pushing your luck and you pushed a little bit too far. It cost you $15,000 to make this trip. You took, you know, you have pit crew, all this stuff. It cost you $15,000 to get to the East Coast and back, right? So you want to save $5,000 on your engine or $10,000 on your engine, but you just blew $15,000 going there and back for nothing, and you left empty-handed, right? So like I said, these types of practices aren't for everybody, right? And I understand the alternatives and budgeting and stuff like that. Like, I was that guy too, right? But, you know, when you're building a race program, and like I said, you rely on the consistency and the repeatability, and you want your stuff to work correctly, there's not like a geometrical like equation or something like that, that like a stroker crank throws a 2J so far out of whack that you came in here and you did everything perfect and it fucking blew up, right? That's not the case, right? It's on whoever's assembling that, machining that, verifying all of this data, right? If you've measured everything twice, you have a tool. There's a tool, I'm telling you, everything you can think of. I am a micrometer nerd, right? There is a tool to measure everything you could possibly imagine, right? Anybody that says there isn't just doesn't have the tool, right? Because it exists, I can promise you, right? So there is definitely a way to figure out exactly what happened with those motors, and it is not the stroker. Now, I will say this, with higher RPMs, with a stroker motor, you are going to have more harmonic issues and things like that. Balancing is going to become more critical. Rod ratios aren't as good. Does not explain these failures, right? Long-term reliability is probably going to be affected slightly by running a stroker crank, right? But we're not talking, like, we're talking about Formula Drift. We're talking about a motor that needs to be gone through at least once a season, right? Or every off season, the thing needs to be torn down and gone through, and everything needs to get measured, right? So when we talk about it that way, right, like, if that is the case, right, then, and these motors are failing within that window, and they're not making it to the end of the season, then it's definitely something going on with the assembly of it. And sometimes it's tough when sometimes people have, like, this is my engine builder. And then your engine builder has to go out, find a machine shop. This is my machine, my engine builder's machine shop. They go to there, right? A lot of these things, it's like tough for an engine builder to have the tools. And it's like probably the worst job I think anybody could possibly have is being an engine builder. It sounds glorious, but they all seem to come and go, right? Because the reality of it is you can't have all the tools, right? And if I have everything set up and I'm machining something, right? And I'm torque plated everything, right? And then I take it back apart to clean it, right? And I know everything's perfect. If you don't trust your machine shop and you want to go back and measure those bores, you have to put the torque plate back on, you have to reassemble everything, and go through this process again, potentially damaging things in that process, and then to measure it again before you assemble it, right? And then the tooling to be able to measure those things accurately. I get there's dial bore gauges that are $1,000, right? But like, if you want to measure to the same spec that your machine shop did, you need to use the same gauges, right? And so like some of these gauges are $2,500, $3,500, $4,500, right? Like for just a gauge, right? And then I got to spend $5,000 for a setting fixture to be able to set the value on the gauge. Because I can't just buy the gauge, you got the setting fixture too, right? So it's possible for an engine builder to have all these things, right? So time and time again, I see engine builders catching bad raps because of poor machine work. Because how can you measure these things? Like how can you justifiably have these tools? These are tools that are usually reserved for machine shops. So it's tough. Like I don't want to say don't go to your engine builder because they have a place, right? But it's a very tough position to be in as an engine builder. And usually your machine shop has all the tools they need to measure everything. They know it's good, and it's a lot easier to hold your machine shop accountable if they're doing the assembly work, because then they're going to be responsible for everything front to back, right? But oftentimes, like I said, when guys have engine builders, because there's usually always a disconnect there, I see problems with that too, right? Because there's no verifiable way, and then you got one guy blaming another guy, and usually when things go wrong, there's no way to figure out what went wrong, right? So,
I was gonna say, as we go to the last piece, because he keeps saying the same thing, I think it's hilarious as I'm a customer. Every time I've ever had a machine shop, they're always mad at the other machine shop that ever did anything because they're always fixing everyone's mistakes. Like you're literally always measuring and then you're looking at exactly the measurements and you're like, that son of a bitch. So I feel your pain.
I do that a lot, and like I said, it's a tough thing. It's a tough game, man. It's a tough game, and you don't know what you're gonna get, and you have to really trust. And that's why I say, dude, it's 2023. I know shipping is expensive. having a motor built's expensive, and there's nothing worse than having a fresh motor built and it's just fucking dead, right? Because that's happened time and time again, right? Even with my customers, even people on Drift Week. Andy, he came to us. I met Andy first because he had a motor that was probably the worst built motor I've ever seen in my life, and it was done by a machine shop here in Vegas. It was horrendous. It only made it a day. So I built him a new motor, and it only lasted a day. And I was like, fuck. That sucks. But I took care of it for him. It wasn't my fault.
Was it your fault or like install?
No, it wasn't my fault. An injector stuck.
Oh.
And
there's
melted
so
a piston.
many components to
So
all
like
this
sometimes
crap.
you could build the perfect motor, and still something else externally can happen, right?
Race cars are so damn complicated.
That wasn't my fault, but he was a good customer. He came in, just said, hey, what do you think I need to do for this? This is what I'm planning on doing. Took care of him. It was a mess up. I helped bear a lot of that responsibility of getting it replaced. Replaced it. He's on Drift Week. He's putting miles on his car, countless track hours.
His car looked flawless.
No
this time.
fucking problems, right?
Yeah.
So it's just sometimes, like I said, you can't. It's everything. But like I said, that fucking hurts. And I see people go through this all the time.
Yeah.
It sucks, right? And so like if I'm gonna do something other than like obviously you know me, right? Like if I want to make money. I own Vape Taser, right? I go to work, right? But money isn't everything, right? So if I'm gonna do something, I wanna do something I love, right? So I love this because I get to nerd out and I'm constantly learning, and it's such a stimulating, challenging thing. But people really need help. You know, it's sad, but like people really need help. Your machine shop, if they do general automotive work, don't have them build your race engine, right? It's not a light switch, right? If you do general automotive work and you're trying to be competitive, you can't measure everything. You just gotta bang shit out, bang shit out, bang shit out. It's just going on a stock Kia. Who gives a shit? They're gonna get another 20, it's like general automotive repair shop down the street, right? He's doing a head gasket. Just fucking clean it up, put new valve seals, send it on its way, fuck it. Don't, like, and that's the attitude these machine shops get, right? They're tooling. They don't meticulously maintain it, things like that. They can't, right? Because if they're gonna keep things flowing out the door and maximizing profits, they can't do that because they're just limited to the area around them, right? I build motors for people all over the place, and I build race engines, and it's much more critical, the parameters these engines operate under. So it's very critical that everything's perfect in here, all my tooling's perfect, measurements are perfect, everything's perfect, because I'm gonna take responsibility if it's my fault, right? And the thing is the local machine shop just isn't outfitted for that, but like, that's a tough pill to swallow for your local general automotive machine shop, that they're incapable of flipping that switch and doing premium work when they're used to just doing and turning over mediocre work. And there's nothing wrong with that. The general automotive repair world needs that. They can't afford to come in here for every job for a 200,000 mile Kia that blew a head gasket to come in here and make it as good as it was brand new, because the block isn't. The block's got 200,000 miles on it. The customer's hoping to get another 20, 30,000 miles out of it, right? So like, why am I trying to perfect this, right? Just two different worlds, right? The two different worlds don't interact as well as people think they do. And it's unfortunately, nobody ever wants to admit that they're incapable of doing something, right? And doing the best, being the best at something. And it's just a sad thing, right? A lot of egos and things of that nature, and it's an unfortunate thing. But like, dude, you got an LS? Dude, you're in fucking Texas, you could throw a rock? And I know machine shops that this equipment that I'm showing you, that's like crazy, they've got 10 of these. They've got 10 of those, right?
Really?
And you're looking at one, right? You could throw a rock in Texas and find high-end, quality fucking machinists, right? Some of these other areas, not so much. But don't be afraid, man. Ship your block somewhere and just go to people that specialize in your platforms. That's the biggest recommendation I give to anybody, right? Go to someone with a track record. That's not always a guarantee. There's been a couple machine shops that have gotten reputations for building motors for Formula Drift that came and went really fast because they just weren't truly cut out for it. But, you know, do some research. Look at the equipment they have. Ask for data, right? It's another thing, is not a lot of machine shops. You ask for data, you ask for profilometer readings. I promise you, if you go to every machine shop that's in Vegas and you ask them to see their profilometer, no one will show it to you. They don't fucking have it, right? So like, they don't have a fucking profilometer. Like,
in my defense, all this is magic, and I can't read a gauge. So I just have to go pick someone that sounds like they know more than me.
But the thing is like, if you just ask them, right, and say like, hey, can you give me like, you know, like what kind of rings you're using, like what are the profilometer readings, or like what's the RA finish on my surface of my cylinder head, right? If you just know some of these, this is like when I was talking to Jordan, right? He has a BMW repair shop. He's having problems with, you know, cylinder heads getting surfaced and stuff like that. And I'm like, hey, look, this is really simple. Call the machine shop and say like, hey, what kind of RA finishes can I expect with my cylinder head? You know, like because you're doing the cylinder head valve job, right? But then you're also surfacing it, right? He's calling machine shops and saying, no, we can't give that to you. No, we can't give that to you. Bang, he hits one, he's like, yeah, we could do like a, you know, sub 50 RA or better, no problem. He's a CBN cutter, starts breaking the whole thing down, and now Jordan takes his cylinder heads there. Okay. Right? Because that guy knows what the fuck he's talking about. He's actually measuring things, right? If they tell you, no, I can't provide that to you, or like, no, that's like inside information, like our information, we don't share that with our customers. They're full of shit. Don't go there, right? And that's how like I was able to help him. So like you don't need to know everything. You don't need to go in there physically see the gauge. But there's like little things the little tricks that I have in here, right? That if someone were to ask me, I know I would give that to them, and I know nobody else would provide that to them, right? So like, unless they were like a legit machine shop. If you were a legit machine shop, you would have no issues. If you asked me for profilometer readings on your block after it was done, right? If you knew what that was, right? I would fucking, here you go, right? That's not proprietary. I didn't make those numbers up, right? Because those numbers belong to Total Seal. So you can call Total Seal and ask them for the numbers your fucking self, right? Like, why would I protect that information unless I wasn't actually measuring it, right? And so like there's little things that you could do, like little tricks and stuff like that, right? Like if you're gonna do billet mains, right? I already named off a couple people that have this fucking tool, right? Don't let anybody touch your shit that doesn't have this tool, right? And knows how to use it, right? So there's, if you have any sort of inline block, right? So that goes for, like I said, I think with Brangers and advanced cylinder heads, and there's gonna be some other people that have this as well. I just don't know all of them. Those are just the ones off the top of my head that I know of for sure. But they exist, right? And you're doing billet main caps. You want, like, it doesn't cost more money because I can get it done. Like that shit takes me all day, right? Because of heat, I have to mitigate heat. I don't have to mitigate heat on this, right? So like, it doesn't cost much more money to do this than it does that, right? Because this takes me less than half the time to do. So we actually talk about labor hours, right? Labor hours are more expensive to do this than this, right? But it takes fucking half the time, right? So like, don't be afraid of some of this stuff like, oh my God, that's such an expensive machine and tool. Like I could never afford that. It's so much more efficient that it doesn't really cost more money. So like you shouldn't be afraid of some of this stuff, and you should be looking for these things when you're doing things like billet main caps and stuff like that, because this stuff exists and is available to everybody. And if your machine shop does not do enough inline blocks to justify this tool,
don't take it there.
Then go to someone that specializes in inline blocks, right? Exact same thing. If you're not sure who to tune your car and you're like going through local tuners or whatever, dude, there's somewhere in the world that specializes in your platform, your ECU, whatever, right? We have this thing called the internet these days, and it's really crazy. They just remote in, and they could be fucking they could be sitting on a fucking beach in Bali tuning your shit. Who gives a fuck, right? But it's worth that extra little bit of effort to ensure that you get your money's worth, man. Because like I said, like one fucking mistake, you could lose everything you worked for. And it's just not worth it. It's not a worthwhile sacrifice. Like if that is it and you're just tapped out on your budget, maybe you should tone things down a little bit and go in steps. But like make sure, because like what's worse, right? Like if you could barely afford to get to this level, right, of quality, right? But someone makes a mistake and you lose all of it. What are you left with? You have to start over with $0? You're done, you're out. I see so many people come in this industry, come into drifting, right? And they start, I think they need to build FD level cars in their fucking garage for their first car build. And it's like, what are you doing? No, you don't. And they get so, and then they're riding a razor thin line because they don't know what's what, and they're trusting people, or they're trying to cut corners or get it done, and then something breaks. And they have no money. And the next thing you know, they're selling their project, and they leave the sport because they were just completely tapped. And I see it time and time again. We do this a long time, man. And it's like that. Like it's crazy how fast some people come into the sport, and how fast they leave. And it's
as someone that hosts events, I see that specifically.
If they could have built something more reliable and got more seat time and focused on that rather than building the baddest car, they wouldn't be there. But when you're riding that razor thin line, one little mistake, if one little mistake could tear your whole operation down, and you don't have the money to recover from it, That's fucked up, man. Like, there's no coming back from that in a lot of cases, you know?
The cool thing a lot of your customers have going for them is the JZ is such a resilient platform that's so well made from Toyota. Even when a lot of us screw up and we're not good at something, they take an amazing amount of abuse, and they're very durable motors.
It's incredible what they're able to do from the factory, man. A lot of customers, we had this conversation, I recommend them, like, buy OEM short block, right? Like, depending on what they're doing. Like, you don't need me for everything, right? Same with LSs, right? It's like, hey, I need 450 horsepower. You don't need me. Go buy a crate LS3, right? Like, that's not me, right? That you're not ready for me yet. And that's okay, right? Because at the end of the day, right, if you're ever gonna have longevity in something like this, it's more important that I do right by every single person that walks in the door than I try to collect money from every single person. And that's the reason why I do everything in my power to not advertise. We stop posting on social media. We try to delist ourselves from Google, everything. And I've got a line of fucking motors, right? Because we do right by people, right? Like, and that is the difference maker, right? So if you do right by people, there is a lot of people that really need help, and they'll spend money. And some of these machine shops, they just don't get that, you know? And you don't put, they're afraid to put themselves in that situation because what if nobody shows up? But if you take care of people, they will show up, man. They will, and it's crazy, right?
As we finish up,
you want to see some of the stuff?
I want to see some of the pistons and stuff. I want to see some of these wacky parts.
Let me see, David Garcia. Let me find the stuff for Forrest build.
Okay, you want to pause it for a second?
So here, this is our little assembly space. It's a little cramped. This guy's car is loud as shit, but you know, we'll make it work. This is actually Forrest Wang stuff right here. This is all the stuff we've been working on for him. This is a cylinder head. OCD Works did the port work. We don't do any port work in-house. I truly believe that port work is something where you need a CNC machine, a 5-ax CNC to do port work, and you need a flow bench, and you need to really know what you're doing when you're designing a port, right? Hand porting is not something we really believe in here. I don't personally believe in. You can't create the same consistency and evenness by hand that you can with a CNC machine. And I think it's important for the consumer to always get the best possible product, right? So I would rather either sub that out to someone else or send the customer to somewhere else that does do quality port work. OCD does do very nice work. This is one of the heads that they had built for Forrest. We had gone through it, we had changed and reconfigured a couple things about it. There was a couple issues that these heads have been kind of experiencing throughout the season. So we made some improvements for this year. I think it's gonna help with reliability, service life. I think when we go back through the head after this season, we're gonna be able to continue to learn a little bit more and put a little bit more into it. But basically it just has, stainless valves, super alloy or Inconel exhaust valves, solid lifter, or shimless bucket conversion. It's clearanced for cams, like larger cams. I believe he's using a BC Stage 3 Plus race cam. He's sponsored by BC. We also use I-beam rods. These are the BC I-beam rods. These are actually, right now, this is, I don't want to say anything bad, but this is surprisingly like the nicest rods that we get when it comes to machine work. I used to not feel this way. I used to be a very anti-BC racing guy. These are phenomenal though. The finish work on these, the consistency of them, these are incredible. So we push these a lot. I-beams, 625 hardware, we're kind of like in that realm of like, we almost treat this like it's, if it's like a 900 horsepower drift car, we treat it as if it's a 1300 horsepower street car, kind of, right? Like, we always try to take an overbuild because that's the type of stress that we're seeing in relation to it, right? Like, a 900 horsepower drift car's seeing the similar loads and just stress on parts as a 1400 horsepower like drag car, street car would see, right? Pistons. So these are actually CP pistons. So this is our own custom CP piston. They don't really believe in skirt coatings. We do, especially on something like coatings, I think are important on engines that see service intervals, like race engines, right? So coated bearings, coated pistons, and what that does, that protects the crankshaft from a little bit of wear to make sure that when we go back in, we can just polish things. Cylinder walls, we want to make sure that we can go in and we could go a couple seasons, 2-3 seasons, without having to go back and bore and go through the cylinders and open them up anymore, right? And take material off, because we want to get the service life out of these motors. These pistons aren't like anything really super groundbreaking. There's just a couple issues that I have with some of the pistons that are on the market, right? So standard height for a piston, compression height, is at a 0 deck level, right? So, which means that in a factory 2JZ, the top of the piston sits perfectly flush with the deck surface, and that's what it's designed to do, right? And aftermarket companies, they copied that piston. They designed based off of the factory piston. The problem is I get a block and I have to surface it and get a quality surface finish on it. I'm cutting 2, 3, 4, 5 thousandths off the deck of the block. So now the pistons stick out of the hole, right? And the problem with that is now the head gaskets have to get thicker to compensate for that. So every build that we do, especially race engines, we take the cylinder head, we bolt it on the block, we measure piston to valve clearance, and piston to cylinder head clearance. We usually use putty or Play-Doh or something like that. Then we use the thinnest possible head gasket we can get away with, right? In a combustion chamber, when you have things like detonation, your weak spot is always your head gasket. That's always going to be the softest material in there, and it's going to be the first to go, right? So the thinner we can make that surface, and the less visibility it has in the combustion chamber by being thinner, the stronger it is, right? So that's why, like, these have a 5,000 shorter compression height, so they sit a little bit shorter, so that way we can stay close to 0 after the block is machined, which is kind of crazy. I have to make a custom piston for that. They use 1.2 millimeter rings, so I believe standard on CP is 1 millimeters. So these are the HD forging, the heavy duty forgings from CP. We use a 1.2 millimeter. We want a stronger ring pack in there than they offer because they come standard with chrome rings, chromoly, and we use steel very often. We feel it's more reliable, and with steel we want to be at 1.2 millimeters, not the 1 millimeters, especially at these power levels. I just actually talked to Justin. We were going to do a second ring that was gapless with a standard conventional top ring, and this, since we were doing nitrous, but we actually, after consulting with Total Seal and going back to them over them again, we're actually going back to a topless top ring again, but a chromoly one this time. So we are going back to chromoly, but at 1.2 millimeters thick instead of 1 millimeters. And then we have heavy duty wrist pins, things of that nature built into this as well. But that's pretty much the gist of it. And then the only thing that's different about this is we have gas porting. The plan this year is to switch to nitrous, which we talked about. Nitrous, especially if you're triggering off RPM and things like that, I'm not exactly sure how they're going to run their nitrous, right? But you're rolling nitrous into the motor and you lift, right? And then you have some unburned nitrous left in there, right? You need a place for that nitrous to be able to roll off and escape. Because if you get back on it and you have nitrous pooled up, you could have bad detonation problems and things like that. Also, the gas porting, where it drops in behind the ring. So it's kind of hard to see in there, but it's offset in deep enough that the air coming through here actually is behind the ring. So it actually helps support the ring up against the cylinder wall, help it seal more consistently, and there's power there, right? But typically in a lot of motors, you don't have the ability to keep the gas ports clean, so they're kind of negligible in most applications. Nitrous will continuous use of nitrous will keep cleaning out those ports and make sure they function properly throughout the entire season. So nitrous is a nice addition, and gas porting was super important for this.
Did the little holes weaken the piston at all? Do you have to think about that and compensate or anything?
Not really. We haven't experienced any issues with that. The locations of them, obviously the holes, we're drilling holes in it. It doesn't have the same integrity that it once did, but it's not something where we have any issues. It's not something in any form of racing or any type of motor where gas porting is really causing a lot of issues. There's actually other ways to go about this as well. I still feel like good old-fashioned gas ports you cannot replace.
Is that
right?
a common thing? I'd never seen it
Very
before.
common, actually.
Oh, okay. I didn't know that.
Especially when you talk about nitrous, it becomes a standard almost when you're doing nitrous. Some people get away without doing it, but anytime you have a nitrous application, this should be fairly standard. There are other applications I've seen this, like Manley makes a very good piston as well. Their Turbo Tough series that has gas porting in it. That is also like a viable option. Still, I haven't seen enough evidence to show me, like long-term, that ethanol can keep the gas ports clean enough, but they come standard in their pistons. Any type of regular gas will clog these up instantly without nitrous. So if you're not running nitrous, methanol, if you're not, like, depending on the type of fuels you're running, it's hard to take advantage of these. We do have a couple customers that opted to go the Turbo Tough route, because it's the only other piston on the market that has a 1.2 millimeter top ring and a 5 thousandths lower compression height. It's the only shelf piston that has that, right? Which is why we have to custom make ours, right? So we do have a couple customers that opted to go the Turbo Tough route that are running 930 to 950 wheel horsepower drifting, and I'm hoping to eventually get some of those motors back to refresh. Those guys aren't competing in Formula Drift, so they're not refreshing seasonally. But they're both on ethanol, to see what the long-term impact of ethanol is on gas ports, because there's really not a lot of good data to show that we could really capitalize and take advantage of gas porting with things such as ethanol, right? Because we have to have something to be able to clean those gas ports. Now, there are such things as a lateral gas port. So you have, on your ringlands, you have small cuts going around there, so that way air can come in through and get behind the ring still. They're not anywhere near as effective as a vertical gas port, but they don't clog as easy. But lateral gas porting is, like I said, the benefit of it is especially if you're doing nitrous, you need the vertical ones, right? Because you have a way to clean them. You have nitrous, right? So that's like the biggest downside to gas porting is, like I said, you have to clean them. But that's where, like I said, nitrous, it's critical.
Just need to sign something. They wanted to re-sign this paper that we sent over to Wells Fargo.
I'm like literally shooting a video.
You're good. We can cut.
Oh, I didn't know that. Sorry.
That's okay. But yeah, so gas porting plays a definitely important role when we talk about nitrous applications. So like I said, we're making some changes to his motor this season, and that's just all it is, right? Like every season we go through, we collect data off the old motors that we go through throughout the year, and then we sit down and we make adjustments and we make improvements. And we always talk to our vendors, we lean on our vendors to ensure that, you know, it's not something that we're just coming up with, right? We bring in as many people as we can and brainstorm with as many of our vendors as we can to make sure we're bringing the best ideas possible, and we're exhausting every resource possible to make sure that we're getting the best possible results and outcome.
How about that crank?
This is literally a factory crank. You know, this is the recipe. This is the 3-liter crankshaft, right? I don't feel like we're in a power range. This is a forged crankshaft. Now, there are crankshafts out there. I believe Cali's makes them. I believe BC makes them as well, that are factory stroke cranks that are aftermarket forged that look really nice. We have not seen any failures with these crankshafts outside of, like, I have seen failures with the crankshafts, but it's been really dumb stuff. Like, they messed up, like, externally. I've seen some really weird concepts of, like, anything from belt tension to, like, you know, wonky adapter plates for transmissions. And I've seen a lot of issues with crankshafts, but under the proper circumstances, I see no issues with crankshafts. This is kind of a good example of, like, some of the things that we're able to do, right? If you look at this crankshaft, it looks shiny, right? I didn't do anything special to this crankshaft. So this crankshaft was washed. We polished the journals. We mic'd it, we made sure everything was straight, we balanced it, and then we ultrasonic cleaned it. So this is another thing that we didn't really touch too much on, was cleaning, right? Ultrasonic cleaning when you have blind holes. So on a JZ crankshaft, you've got passages that turn 90 degrees as it passes through these journals, right? And they're very small passages. There's no way to get a brush down in there to clean that. So having things like ultrasonic cleaning capabilities, we also have, like if they're really bad, the cranks are nice because we could pressurize the cranks and pull sludge out that way. One of the most common mistakes I see with crankshafts is they don't pull the oil galley plugs out. That is the #1 thing. In fact, I've seen countless motors that have come from other machine shops, and I've never seen one come from another machine shop where they pulled the oil galley plugs. And I've had people come in and be like, dude, my crank is so clean, it doesn't need it. And I'll sit there and I'll pop a ball out myself right in front of them and pressurize it with air, and it's like a black snake of sludge that comes out because it sees so much heat on these journals, right? And so I could actually show you on this crank, if you look at the back side, there's a pipe plug right there. So every single one of these crankshafts gets the balls pulled out. So they're like little steel balls, right? That get pressed in. And a lot of people don't want to do this type of stuff because it's a fucking pain in the ass. But the balls, we use a stud puller that we weld a rod to. Each ball, we pop them out, and then we have to go through, we have to drill each hole and tap them. And trust me, tapping forged cranks is not the most fun thing in the world to do. Every once in a while you snap a tap, it's not a good thing, and you have to find ways to get it out, and it can be a little frustrating, but it's very important that you clean those oil like that. Like, you know, we're talking about returning this to as good as it was new. And that same condition, if it's full of sludge when you're done with it, but then how do you clean the blind holes? And that's where like ultrasonic cleaning comes into play. This outside of this crankshaft is not polished. This is what our cranks look like when they come out of our cleaner. I don't have more in here. They're all installed. Okay, so every motor's got a crankshaft installed. I don't have any more sitting around right now, but it's critical. Like I said, cleanliness is everything, right? Like, these are like any little bit of dirt, right? Like same with any block, right? Every time a block comes in here, like my guys, they take a rag, they soak it in brake cleaner, and they wipe the cylinder walls, and they run it along the side of the block. And if they could get, like, if it even turns the faintest gray, that block leaves the room, and they have to go do it again. Because if you could find a speck of anything on a motor, I don't want it in here. Like, cleaning is everything, right? Because that's stuff that circulates back through your motor, and that stuff builds up over time, right? But like I said, if I'm saying this motor is as good as it was when it was new, then it needs to be as clean as it was when it was new as well. And those are just like important details that go into this stuff. But like I said, this is really simple. It's just a factory crank. There's just we've experienced no failures with this. And if you're willing to stay 3 liter, we haven't seen any reason at these power levels to make any sort of adjustment.
All right. Well, thank you so very much.
Absolutely.
Side point the camera at me real quick. I'm just going to say something. I just want to say thank you to Chris Finch. He's always around Drift Week. This is so cool to get a tour of all this stuff, see exactly what goes into a Formula D motor, see how all the machine work. Well, we didn't see exactly how it works and stuff or learn too much because everything is too complicated for me, and I'm a non-evolved monkey. But I wanted to say thank you for all this that he showed us, all the stuff that I try and learn and stuff. Oh, they're 10-to-1 compression pistons. He didn't even say that. But one thing I did want to say is this is so much freaking work. There is so much stuff going on here and so much effort and so much measuring and everything else. It is bonkers. You can just buy a factory short block from Toyota who literally has to make the castings and make everything, and they're like $3,600 or something. Like,
you can't beat it.
Yeah, it's insane. And like, he's telling you to go do that unless you want a full race motor. So I was gonna say, I mean, go buy those damn things for $3,600. It is a steal considering how much effort he has to put into this and how much effort the Japanese did originally making all this. Because you're getting
all of the castings, you're getting all of the pistons, rods, crank, everything brand new. It doesn't even have to be cleaned or anything. It's insane.
Well, the reality of it is, if you're
Toyota,
if you're Toyota and you're doing a production run of 1,000 engines, right? The efficiencies that you could build into that, right, to bring the cost down are incredible. I can't build those efficiencies. I'm building one by hand. So those efficiencies can't exist here. So there's no way that I could match the cost of an OEM short block. And the OEM short blocks are very competent. We've seen it time and time again. But for competition use, they're not it, right?
Yeah, it's not a race motor.
It's not a race
motor. There's very few people that really need a race motor.
Yeah, you're drifting, you're doing drift week, whatever it is. There's a lot of value there. There was a long period of time where you can go to the importer and you can hand pick a very clean, low mileage motor. And those days are gone. They're gone. Stop it. Those motors are junk. All that's left is the garbage, right? And so if you're going to spend, like, and the price is ridiculous now. When they were 2,000, if they were garbage, like, who cared, right? Just buy another one, right? But now they're $6,000 for a used motor. Just stop, right? Like, go, like, dude, like, even then, like, we use a lot of the NA stuff, very inexpensive. NA cylinder heads, I've got several guys running NA cylinder heads, 900 to 950 horsepower, drifting competitively on NA cylinder heads. It takes a little bit more machine work, but the heads, they're free. I've got pallets of them, right? Like, and I just give them away, right? So
then you don't get to use the factory intake manifolds and everything, do you?
Not the factory GT stuff, but
Yeah.
you could use aftermarket stuff, and there are some cost-effective options. Like, I try to make sure that I have cost-effective choices for people. So everything from like cast turbo manifolds in stock, like Borg Warner, like journal bearing turbos. It could be done very inexpensively, like Spa turbo, like intake manifolds that are relatively expensive, like $700 or $800, all the way up to like Hypertune, sleeper designs, like the $2,500, $3,000 billet manifolds. We have something for everybody, right? Like, but I really, even though, like, let's just say it's not something I use in my own personal car, right? My situation is everybody. I'm always trying to find ways to figure out, like, how to do the most with the least budget, right? But then, but like, my idea of that might seem a little bit ridiculous to some people because it's still kind of expensive. But like I said, also, like, oftentimes I could be the wrong person to even get advice from because like, I have to, like, not just sell you a part, I have to guarantee it works, right? So like riding that line, I can't do it, right? Because I can't support what I'm doing and unsupport those customers on those products if I'm just on the line. And then if things fail and I don't take care of them, that's my reputation, right? So I can't sacrifice my reputation to help someone cut costs in their motor, but I understand why they're doing it. But we do sell a lot of parts and alternatives and things like that to bring the cost and make it as reasonable as possible. And we do try to manufacture some of our own products to make the cost a little bit more reasonable, whether it's like billet main caps and tensioners, our own valve covers, things like that. We're working on making some of our own spring kits and things of that nature to try to give people like a little bit more affordable options. So that way, and being cost conscious. And then we also try to make high-end stuff as well. And we try to bridge the gap between the two to bring people like this type of quality, right? Like this type of precision, right? And like I said, the thing is like, if you want precision, when we talked about things like balancing and the importance of it, right? We talked about the precision of it, right? Like, you're gonna get that when you buy a new OEM Toyota short block, right? You just don't have the strength. Like, you don't have stronger, like, I'm building motors with aftermarket piston rings that are stronger, hardened bearings that are stronger, right? You're not gonna get the mileage out of them, but they're more detonation resistant, things of that nature, right? So there are some advantages to what I'm doing, right? But for the average person that wants to make 500 horsepower and go bang limiter all day at the track, like, that's a very viable option. If they want something that's fresh and they don't wanna gamble, right? They don't wanna keep buying motors, right? That is a very, very viable option, 100%. And like I said, we've had this conversation, I don't know how many times, like, where I push my customers to go buy this if it fits them, right? So at the end of the day, right, like, the customer just has to have the best experience possible here, you know? So anytime we could do that, we'll do it.
All right. Thank you so much for your time, Chris. All right. Goodbye, audience. Goodbye. Tell them bye, Chris.
Bye.
Bye.
Another quick shout out to the sponsors since we can't do it without them. This whole thing was filmed within Just Racing, so you should get a good vibe for that right now. They sponsored this whole series of Drift Week 7 content. BC Racing Custom Coilovers, who is the most supportive coilover company on earth for drifting and everything else, I think. They're awesome. Thank you so much to whatmonstersdo.com. They have a new logo, which is on the right of their old one, which is on the left. Go to their website, use the discount code EBISU. They should be restocking merch soon. Vapetasia, who is also Just Racing, who is Chris Finch, who is in this video. Thank you so much to Vapetasia. NK Wheels, I've been running their wheels for more than 20 years now, which is crazy. So thank you so much to NK Wheels and the RPF1. My favorite wheel on earth, Valino Tires. Thank you to Valino Tires for supporting Drift Week, bringing Naoki Nakamura over. Naoki, I always say that wrong. And also, thank you so much to Heatwave Visual. Thank you so much, Heatwave. I'm sure you saw me wearing their hoodie this entire episode and all the episodes on this trip. That hoodie's getting worn out. Bye, everybody.